Okay, everybody, welcome back. We're doing combinations here again, a continuation from the last problem I did. Instead of calculate the different ways to get a full house, or the number of different ways to get a full house, we're going to calculate the number of ways to get straight. And again, if you're not familiar with poker, a straight is a sequence of cards that are all in order, so like 1, 2, 3, 4, 5, or maybe I should say like ace, 2, 3, 4, 5. But it's 5 cards where the sequence follows. The suit doesn't have to match, but it has to go in a linear order like that. But since you can be dealt these cards in any order doesn't really matter. You can rearrange them once you get them. It's going to be a combination, just like the last one. Okay, and I'm going to go straight through this problem really fast for the people who are a little more advanced and a little more comfortable. So the first C I'm going to use here, 52 for 1. You've got 52 options. You pick one card. But then after that, there's only 4 cards out of the whole deck that follow that. So if you pick an ace, there's only 4 2s that can come in. So you've got 4 options. You can only pick one of those. And then after that, you've only got 4 options. You can only pick one of those. So this is like for the ace. This is for the 2. This is for the 3. And then 4 options. Only pick one of those. This is 4. And then 4 options. And 4 options. And you can only pick one of those. So, and that would be the 5. So these are the combinations that would give you 5 cards straight. So then, if you're using the equation in factorial, all over in factorial, and r factorial, n minus r factorial, then this is going to go to this combination with the C and everything else. I'll actually move this down here so it's a little easier to see. Keeping in columns here. It's going to be 52 factorial all over 1 factorial, 52 minus 1 factorial, times 4 factorial all over 1 factorial of 4 minus 1 factorial. Now I'm going to go ahead and reduce these very quickly, and you know that the next one is also going to be the 4 factorial, 4 factorial, 4 factorial, since all these C's are just the same. 4 factorial, blah, 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 blah. Doesn't really matter that much. But now you get the idea. That's the equation that's going to be going in each one of these new places. I'm going to straight reduce here. If you have any questions about that, you can see the previous video. Okay, so moving on with that, we have 52 times 4 times 4 times 4 times 4. And then if you calculate that out, that will actually equal 13,312 different ways that you can get a straight. So hopefully that's a nice refresher for you if you were already familiar with combinations and just need a little bit of practice. Alright, see you guys later.